Hi, my name is Anthony Boyd, and thank you for looking at my cool tool, which is a project called Google Finger or Soli. And for the purpose of this, what I'm going to do is start off by watching a small presentation produced by Google or Soli. We're going to only present or watch a small presentation of this. Um, and for the purpose of that, it's best explained. I want to keep in mind that this is the reason this is best explained by a video is this is not an application or a platform that you can just go in and click and sign in and then implement into the classroom per se. This is a ground floor application that you're going to have to understand and know that this is something that's 5 or 10 years out, for education or even the general marketplace. And it's something that's still in product development and that's still trying to be understood and worked through. For all intents and purposes, I just want to go ahead and start the video here, and then I'll go through and I'll probably stop it, and then we'll go from there. So thank you.
My name is Ivan Pubarev, and I work for Advanced Technology and Projects Group at Google. The hand is the ultimate input device. It's extremely precise, it's extremely fast, and it's very natural for us to use it, right? Capturing the possibilities of human hand was one of my passions. How can we take this incredible capability, finesse of human actions, of finesse of using our hand, but apply it to the virtual world? We use radio frequency spectrum, which is radars, to track human hand. The radars has been used for many different things, to track cars, big objects, satellites and planes. We're using them to track micro motions, twitches of human hands, and then use that to interact with wearables and Internet of Things and other computing devices.
Our team is focused on taking radar hardware and turning it into a gesture sensor. Radar is a technology which transmits a radio wave towards a target, and then the receiver of the radar intercepts the reflected energy from that target. The reason why we're able to interpret so much from this one radar signal is because of the full gesture recognition pipeline that we've built. The various stages of this pipeline are designed to extract specific gesture information from this one radar signal that we receive at a high frame rate.
From these strange foreign range Doppler signals, we're actually interpreting human intent.
Radar has some unique properties when compared to cameras.
I think it's really important to note that when he states, we're able to capture human intent, we use several applications every day, and we force our applications to describe what we want it to do. And in this application, it's describing it's describing us. It's interpreting us and our intent. So it's capturing our essence, not what we're trying to. We're not telling it what to do. For example, when we press the letters on the keyboard, we're telling the Word document we want the letter H or we want the letter L. We're in essence, we're still doing that, but at the same time, it's capturing our intent of our motion, and in essence, our emotion is our intent, and it's the human motion, and us simply striking the keys on a keyboard is no essence of a stamp on a mill pressing out a mold in a factory. And so this technology is very different in that matter. So it's very different, and he's going to talk here about cameras. So when compared to cameras, for example,
it has very high positional accuracy, which means that you can sense the tiniest motions.
We arrived at this idea of virtual tools because we recognized that there's certain archetypes of controls, like a volume knob or a physical slider, a volume slider. Imagine a button between your thumb and your index finger, and the button's not there, but pressing this is a very clear action. and there's a natural physical haptic feedback that occurs as you perform that action. The hand can both embody that virtual tool, and it can also be acting on that virtual tool at the same time. So if we can recognize that action, we have an interesting direction for interacting with technology.
So what does this mean all for the classroom? I think this means a lot of things. Adaptive tools and technologies. I think this means that we change the way that we utilize that in the future, especially for our special special needs students. I think that that need adaptive tools and technologies. I think that it also changes the way that we interact with our regular ed students. I think that it also changes the way that we live our everyday lives. When we look at applications and things like that, it's mostly we're talking about wearables, phones, watches, things like that, computers, cars. But at the same time, this device has its potential is limitless, and I think that's something that's very important to note because its imagination is left up to the designer, the platform, the user, and I think the development is going to evolve, and I think we're going to see it in very many different applications in years to come. So I appreciate your time, and I look forward to seeing what else we have to go from.